So classification of elements. We're really going to look at three main classification of elements, but then we break down those classifications, those three main classifications even further. Now we have metals, nonmetals, and metalloids. Metals. Back in the day when metal was big, as far as the music, we'd say we were into metal. And we weren't really into this sort of metal, but more metal music. And I think the term heavy metal came about probably because everyone used to wear these metal studs in their jacket, their face, their pants, their boots. Everyone used to be decked out in metal. I'm not sure if that's why they called it heavy metal or not. But it was big back in the day, but now, you know, we listen to other music, which is fine. So metals, what are the characteristics of metal? Elements that are shiny, smooth, and clean. They're solids at room temperature. In fact, most things are solid. Most elements are solid at our room temperature here on Earth. Good conductors of heat and electricity. So they conduct very well. That's why you're not supposed to stick a fork or any other metal in the electric socket. You really shouldn't stick anything in an electric socket, even your finger or your hand. Malleable. What does that mean? It means that you can hammer it into a flat sheet without it breaking. Now, if you look at something like a crystal, you can't do that with a crystal. It would break. But a metal, you can. Ductile. Ductile is similar to malleable. You can draw it out into a wire. Thus, we have all our wires made out of metals. And of course, because they're good conductors. Now, all groups B and most group A elements are metals. The staircase line is divided between the metals and nonmetals. And this will become more apparent as we look at it. Now, almost all elements on the left side of the table are metals. What is the exception? Hydrogen. Okay, so hydrogen is not a metal, even though it's way over to the left. It's put there for another reason, which we'll get to. Here we can see the metals, and we'll get to the metalloids and nonmetals in a minute, but here are the metals except for hydrogen, and there's a dividing line. See that little staircase here? That's the dividing line between metals and nonmetals. We'll discuss what these purple are and what the other ones are, but you can see most of this atomic chart is our metals. We can break down metals into many different groups. Two of them are the alkali and the alkaline earth metals, and they're very similar, and they're similar in position as well. Now, what does alkali mean? That means basic. Now, that doesn't mean basic as we know it, but really as in acidic or basic. So alkali metals are the group 1A except hydrogen. So that's the very first column on the left. So really, you guys, if you can have your periodic table out now or the one in your book, that would be great. The alkaline earth metals are group 2A. So remember, group is a column. Group 1A is the first column. Group 2A is the second column. Now, both alkali and alkaline earth metals are chemically reactive. They react. They are very reactive. Alkali metals are more reactive. Why do you think? Valence electrons, those are the outer electrons. So here we have the periodic table of elements. Alkali metals, right here. Alkaline earth, right here. So 1A except hydrogen is not an alkali metal. It's not a metal. And then we have alkaline earth. Now we're going to get to the transition elements, and there's two sets of them. These are the main transition elements, and down here are the inner transition elements, also called the rare earth elements. Now, they're actually not rare earth at all. They're very abundant. But what happens if you can see here, barium is 56, and then it skips all the way to hafnium, well, that's where the lanthanides come in. 57, through 71, then it picks up with 72 hafnium. And then down here, radium goes to actinium, 89, through 103 and picks up at 104. And why'd they do that? Well, they have the same basic properties. They also, these inner transition elements, the rare earth, have their sublevel F. That's their last sublevel. So let's look at these in more detail. Two categories are of transition metals and inner transition metals, also called rare earth. Now the inner transition metals, the rare earth metals, again are not rare at all. In fact, the first one, we have two sets, the lanthanide series, starting with lanthanum. Lanthanum is one of the most abundant elements on Earth. Now the top row of the inner transition elements are the lanthanides. They're chemically identical. The only difference really is magnetic properties. Now all but promethium are stable, as opposed to the actinide series, which is the bottom row. All are radioactive. So the bottom row of the actinides, or the bottom row of the rare earth, they're radioactive. The top row are stable except promethium. So here again we have your lanthanides. They're all stable except the radioactive promethium. And then we have the actinides down here. We don't really spend too much time with these elements. Now the transition elements that are not inner transition, that's like that big block of elements right in the middle of the periodic table. So we see this on the actual periodic table. Okay, you can think of it as the continental US. And maybe the other ones are here's like the continental US. And, you know, these two can be Hawaii and Alaska. We get into metallic bonding and more in detail, we'll see about these. You know, we have the zinc, copper, gold, silver, cadmium, nickel, all these very important. Mercury, zirconium, these have their own specific properties to them. And we'll talk about their bonding properties and really what makes them metals later on. But just know for now that these are the transition metals, this big block here. So let's look at the classification of elements, the nonmetals. The nonmetals occupy the upper right side of the periodic table. They're right of the staircase. They're usually gases. They're brittle, dull looking as solids. So if they're not gases, they're going to be pretty dull solids as compared to metals, which are quite shiny and lustrous. Nonmetals are very poor conductors of heat and electricity. Thus, they're going to make good insulators. So if you're a poor conductor, you're a good insulator. Like styrofoam, of course that's not an element, but that's a poor conductor, but it makes a good insulator. It stops the flow of heat and electricity. Now, bromine is the only metal that is liquid at room temperature. Now, the important nonmetals, we can group these as group 7A. That's the halogen group. Now, the halogens are extremely reactive, very reactive, especially fluorine. Now, if we look over at the alkalis, way over here, we have these guys extremely reactive too. And we're going to get to periodic trends. What does that mean? Why are they highly reactive? The valence electron. It's all about how they react. It's all about the valence electrons. Group 8A, the noble gases. Noble. they're very unreactive. I mean, they're just not reactive. They don't react really at all. In fact, that nobles are noble. They're superior. They don't have to deal with anyone else. Here are the nobles right down here in this column, the far left. They are superior. What do nobles do? They don't deal with the peasants. Everyone out to the left is a peasant. They're just lowly, real elements. So these nobles are so stable, so superior to the rest of us, they don't even interact. How can we remember this name of the halogens? Well, these are the noble, and nobles just think they're God. They're just superior. And so next to God are angels. They have halos. So halos are angels, halogens sit next to the nobles. That's one way to remember it. Now xenon was caught slumming. It actually reacted with fluorine. Fluorine is so incredibly reactive, it got xenon to react with it. Now why? They have 8 valence electrons. Helium actually has 2. What does that mean? It's a full energy shell. Now let's look at metalloids. So a metalloid is basically has characteristics of both. Hey, that's pretty cool, isn't it? A little spinny thing. Here's the metalloids, opposite side of the staircase. Here we have the nonmetals. Metals over here to the left of the staircase. Here on both sides of the staircase are the metalloids. To the left, of course, are metals. To the right are nonmetals. Now, where are the metalloids? On the top of each of the staircases, or to the right of each of the staircase, and to the bottom, except aluminum is just a pure metal. So if you can remember, the elements surrounding the staircase are all metalloids, except aluminum, which is just a pure metal. So they are elements with both physical and chemical properties of both metals and nonmetals. So they have the same properties of both. For example, silicon and germanium. Now these are extremely important if you've heard of the Silicon Valley. Silicon Valley in Northern California, that is the hub of all computer activity. And why is it called the Silicon Valley? Because silicon is the basis of computer chips. Now germanium, anyone know why? Well, no one's answering, so I will just tell you, is using computer chips and solar cells. So germanium used in solar cells. This is silicon, germanium, just a few of these important metalloids. So there are many different links you can look at different elements. This is really cool. You can hear about them. There's lots of different periodic tables you can click on and look at the pictures and read about them. But I like this one a lot because you can hear people talking about the elements. So you can click on any of these.
Chemistry in its Elements, brought to you by Chemistry World, the magazine of the Royal Society of Chemistry.
And
this week, we hear what it's like to be at the top and number one, as we meet the king of the elements. Here's Brian Clegg.
Forget 10 Downing Street or 1600 Pennsylvania Avenue.
Okay, I'm gonna.
The prestigious address in the universe is number one in the periodic table.
I just wanted to give you a little bit of that. You can go on and click on any of those elements and you'll hear some cool British dude talking about an element. And when they talk in English accent, it sounds much better than if you sound all monotone like I am right now. But check out the link. It's pretty cool.